Alright, so let's work through some practice problems. We're going to work through each kind of problem that I talked about in the previous video in that order. Okay, so the first kind of problem was, just as a reminder, we have a number raised to a power equals the same number raised to some other power, where variables are in the exponents. Then I can set the exponents equal to each other. I'd really like for you to have a better understanding of why. And if you're fully convinced that this works and you kind of see why it works, then you're in good shape. What I don't want you to do is rely on your remembering, this situation, and that this means that you're supposed to do whatever next, like a step. Don't think of math in terms of steps, but in terms of the concepts, understanding it, and you're going to do much better. So if you understand why I can set x equal to y, did good. That's where you should be, right? So that's the kind of equation where we have the same base for the exponent. So let's look at number 3. Just start us out. Now the thing that's a little tough about this, if you were doing this on your own, is we talk about this kind of equation, and then right away they give you one that doesn't look exactly like that. I think they should have started you out with one that looks pretty straightforward, where the bases are exactly the same, but they don't. So we need to fix it, right? If these bases were exactly the same, we could set the bases the exponents equal to each other, but they're not. But can we make them the same? Let's look at 25. Think about 5 and 25. Think about maybe not even specifically 5. It won't always be the number that appears here in every problem, but think about these two numbers, and then think about exponents, and think about if you can relate them to have the same base, right? So for this one, I'll just start out. Okay. Now, I'm not doing something to 25. It's a misconception I've been hearing a lot. I'm not doing anything to 25. I'm not changing it. It's just I'm altering the way that it looks, not what it's worth. When you don't change what it's worth, then there shouldn't be this idea that, oh, I should do something to the other side because I'm not doing anything. Right? Just it's changing the way that it looks, not what it's worth. 5 squared is exactly the same as 25. So if I raise this, which is 25, to the x minus 6, these are the exact same thing. I haven't changed this side. I haven't changed that these are equal. So this is good. It's just fine. Okay. So now we've got 5 to the x minus 4. Because remember, this needs to be the base to the power and the base to the power. This is the base like to 2 powers. It's to the squared, the second power, and then it's to the x minus 6. We've got to put them together. Now how do we put those two together? We're raising a power to a power, so we multiply. So it's 5 to the 2x minus 12. All right, now this is 5 to the power and 5 to the power, so these are the same base of 5, so x minus 4 must be equal to 2x minus 12. It's the only thing that makes sense. Let's solve for x. I'm going to subtract x from both sides. I'm going to add 12 to both sides, so I'm going to get 8 equals x. Okay? You can throw it back in there and find out that that is true. Let's try 7. 4 to the 2x minus 5 equals 64 to the 3x. All right, so again, we're looking to have these bases, these numbers down here, be the same. And we've got to think, what base could that be? This is pretty small, so let's think, could we write this as 4 to some power? And it turns out that we can. We can write 64 as 4 to the 3rd power. All right. So now the bases, they're really close to being the same because I got to combine these exponents to make them truly the base of 4. So let's do that. 4 to the 3rd to the 3x, that means multiply these two powers together, you get 4 to the 9x. So now the bases are the same, so 2x minus 5 equals 9x. So negative 5 equals 7x, and x equals negative 5/7. Let's try another one. And it's a little bit different. Let's go to 6. Just go back one. 27 to the 4x minus 1 equals 9 to the 3x plus 8. All right. So in these the previous problems, we just said, oh, 5, let's write this as a base of 5. This is 4, let's write this as a base of 4. So you might look, oh, here's 9, so let's write this as a base of 9. But there's no way to raise 9 to a power and get 27. 9 squared is 81, which is not 27, and it's too big. It's bigger than 27. So what do we do? In this situation, and it's really the same as all situations, you need to think, how can I make them the same base? How can I make both of these numbers the powers of the same number, right? The same number raised to a power. Let's think about 9. 9 is probably the easiest one to think about because 9, it's only got, you easily think about it as 3 squared. 3 squared is 9. So we'll change 9 to 3 squared. Now let's think about 27. Can 27 be written as a power of 3? And it can. It's 3 to the 3rd power, 3 cubed. There we go. Now we have the same bases, and now we just need to combine the exponents together so that we truly have a base of 3. So 12x minus 3 equals 3 to the 6x plus 16. And now 12x minus 3 equals 6x plus 16. Let's solve for x, so we get a 6x is equal to 19. Right, yeah. So x is equal to 19 over 6. Not a pretty answer, but it is the answer. It's a great thing about knowing that you're doing the right thing each step. Don't think about how can I get this problem done quickest, but each step, I'm not just doing a step because that's what I'm supposed to do, I'm doing a step because it makes sense. And when you know that you're doing the right thing, when you get an answer like 19/6, you know you're right. Let's try one more. It's pretty challenging. Number 11. It's 25 to the 10x plus 8 equals 1 over 125 to the 4 minus 2x. Now this seems a little crazy, right? First, it's probably easiest to look at this one. Let's think about the base that we're going to use to get 25. Well, let's think of the number we're going to raise to a power to get 25. The thing that jumps to my head is it's a perfect square, so 5 squared is 25. And that's still raised to the 10x plus 8. Okay, let's think about 125. Does it have somehow a relationship to 5 to a power? Well, if I just look at 125, then I think for just a second, well, 125 is 5 to the 3rd, but this whole thing can't be 5 to the 3rd because this is a fraction. How could we take 5, raise it to some power, and wind up having 1 over a number? Well, hopefully you remember this, that if you raise a number to a negative power, then it's going to wind up going to the denominator. So it's going to be 1 over this number to whatever power I'm going to use. And we just said 125 is 5 to the 3rd, so if we do 5 to the negative 3, we get 1 over 5 to the 3rd, which is 1 over 125. So 1 over 125. 5 to the negative 3, try it out yourself, convince yourself, and remind yourself, oh yeah, 5 to the negative 3 is 125. So when you see these fractions, think, negative exponents. All right, so 5 to the 20x plus 16 equals 5 to the negative 12 plus 6x. So 20x plus 16 equals negative 12 plus 6x. And then solve for x. I'm going to take 6x over here. I'll get 14x. And let's subtract 16 from both sides. We get negative 28, so x equals negative 2. All right, fantastic. All right, Now in your books, you're going to go to the next set of problems, and it's not going to look like the problems I'm about to do, because I grouped these kinds of problems with the next set of problems, which is 24 to 31, where we have the same base of exponents, and now we're going to work with the same base of logs. Okay, that's where I'm going to jump to. So let's start with 24. Log base 5 of 5x plus 9 equals log base 5 of 6x. And remember from the previous video, the moral of the story of these kinds is, first of all, we got a log of something equals a log of something. Nothing else, that's it, right? And they have the same base. Not only are they both logs, they're log base 5, both of them. And if you want more of an explanation of why I'm about to do this, watch the intro video. So since they have the same base, since it's just logs involved, I'm not adding something else over here, then set this and this equal to each other. They must be the same thing. It's the only thing that makes sense. So x is equal to 9. Subtract 5x from both sides. There you go. Let's see if we can squeeze another one on here. Both times.